Hello and welcome, guys. Now we're gonna be talking about thermal expansion. Now, thermal expansion is a something that is caused due to thermal energy. Okay, so in solids and liquids and gases, all of these they expand when they are subjected to what? Well, subjected to heat. We said at the start of this unit that temperature is the measure of the average kinetic energy of the molecules. So therefore, when you increase the temperature, therefore the motion of the particle is going to increase. So in each of these, you're going to find out that the more of the temperature, the more of the collision, the faster the particles are moving, and therefore creating more spaces, weakening the intermolecular forces, and therefore they expand. So this is basically thermal expansion. Okay, as you can see. Now there's a fair comparison between expansion. Now expansion in gases is greater than liquids than in solids due to what? Due to the weaker forces between the matter of gas or liquid or solid. Okay, but you can see the expansion more clearly, or you can basically, it's more sensible in solids than liquids than gases. Okay, this can happen in a lot of applications. Okay, now if you look at these applications, is like where is it? Yes, we can use it as a bimetallic strip. We use it to create thermometers and something's called thermal loosening, where you basically change the diameter or change the things, change the dimensions of some elements using the thermal energy, and therefore it changes, it expands. Okay, now a bimetallic strip is the one they're going to be asked about in Cambridge. Excel doesn't really support bimetallic strip, but it's a good way to know it. Using the thermal expansion also in thermometers. This was in the old syllabus. It's good to know as well. Okay, now basically if you look at this diagram, we have the bimetallic strip. Is from its name, it's bimetallics, made from two metals, each with a different expansion rate. Okay, so let's say copper expands more with heat. So when that happens, the copper wants to move in this direction, but the iron doesn't really want to move. So when that happens, there is a resultant force on the metallic strip that makes it bend in the upward direction, because copper wants to move like this. This resultant force is going to be in the middle. It's like bending it. Basically, it's creating a bend. These forces are creating a bend in the middle, so that's why it bends upwards. And it's reversed when there is cold. When it's cold, it's trying to contract. So when it tries to contract, the bending is going to be in this direction. The resultant force is going to be upwards. So the bend is going to be in this direction. Okay, that's the idea of thermal expansion. Now, these expansion rates can cause problems in so many of our construction sites, or the things that we use basic. Now, these precautions that we should take is leaving some spaces for this expansion, or making our decisions in this engineering projects to create some sort of a space for the elements to expand. Okay, now if you're creating a railway or rails, there is expansion joints between them. Also in aluminum, windows and all of that, there's some spaces that is left for the expansion. Telephone wires, these wires regularly in the heat, in the summer they sag, and in the winter they contract. So you have to leave some sort of a space for them to sag and contract. Other things also for bridges. Some bridges got some expansion wheels that makes it expand, especially steel bridges are such of that. Slabs of concrete, this found mostly in bridges. If you see in bridges, there is some sort of a it's like a speed, but you feel it's like a speed bump, but it's not. It's an expansion joint. Where basically, if this is a concrete slab and this is a concrete slab, in the cold, it goes backward. In the heat, it expands. So as you can see, these forks go inside, as we call it, expansion joints. These are created so they don't allow for the concrete slabs to buckle. Now, what is buckling? Now, buckling is when an object expands on itself and it starts to bend. Okay, so that is buckling basically. You could have a concrete slab like this. Okay, usually it's like that in regular shape. Okay, so let's say you have these expansion joints and it's the summer and it hasn't been clearly fixed. So next thing you know, you come to the road and the road looks like this. And I see it. The road explodes basically and it bends upwards. Okay, wait, let me draw that again. Doesn't look good. So you can see the road can buckle like that. Okay, you'll find the road is buckling. Okay, or if a pole is like this, so let's say this is a pole, it's been stuck in the land and it wants to expand, and the next thing you're gonna find that the pole has been bent like this. This is what we call buckling. Okay, so this is called what? I don't know why the pen is laggy, but again, it's called buckling. Okay, so you want to avoid the buckling by any means, so this is why we use expansion joints. Okay, so if you have any questions, these are uses you can read, not clearly stated in the syllabus, but just for you to read. And thank you for listening.